There we go. I got a nice little overview, and now I don't have to do the rest of my presentation because you have it right there. Anyway, so getting into the goals and objectives of this project, as seen from our nice overview video, we want to apply natural language processing to sensory science and be able to generate what's called a descriptive language from text reviews. And part of the challenge of this is sifting through these reviews to have a mix of relevant and irrelevant information. So we want to compare like what are called descriptive lexicons, a collection of descriptors for a particular product, in this case, whiskey. Want to compare the ones that we are able to do through our workflow to those developed by descriptive analysis, which is traditionally performed by humans. And so some of the things we like to do is examine these lexicons' ability to predict certain aspects of whiskey from text descriptions and produce some visualizations to aid in this analysis, compare results. And we ultimately want to make this open to the public for interaction and learning and things of that nature. So other than the interestingness of this dealing with whiskey, why does this matter? Well, whiskey is an agricultural product that actually has not yet been characterized through sensory science, which I found very interesting. And there are distinct styles which have these different sensory profiles. And as I mentioned in the previous slide, want to perform this descriptive analysis automatically, which normally is very time consuming and expensive because it involves a trained panel of experts. And we'd like to be able to create flavor profiles of whiskeys, which is very important for consumers. Create some comparison metrics between whiskeys. For example, if you have a lexicon for like a bottle of whiskey that costs like $50, and it's similar to one that costs $200, you can actually get an idea of what the more expensive whiskey tastes like by just getting the $50 bottle. This is a simple example. And we believe this can be done with other food products, which is some of our future work. And so we were able to scrape some data from a couple different websites. I believe Laird Hamilton did this, and these websites were, I believe, professionally reviewed, reviews were made by professional tasters. I believe, if I remember correctly. And so our initial steps, we're kind of taking a look at the problem. This is where Dr. Long and Leia were coming in, then they asked me the help where they wanted to perform this descriptive analysis, and they were like, well, how do we do this? Well, how do reviewers do it? And they have this list of descriptors that they use, this specific language for this domain, and like, how can we extract that, this unique language? I thought, well, these are describing aspects of a product, so why not we do parts speech tagging, adjectives and nouns? And sometimes word frequencies can work, but not always. And this first step, you might see, does not include any machine learning yet, which is what we ended up using, and we'll talk about a little bit here. And so we had this initial visualization that was kind of like a quick way to kind of get an idea of relationships between words in these reviews. And this is using correspondence analysis, which is similar to PCA, principal component analysis, for projecting high dimensional data to a lower dimension for visualization purposes. And so this is looking at the relationships between different words, and some are highlighted for illustration. But it's kind of challenging to interpret looking at all of these terms. And so a number of us got together and we helped develop a descriptor tagger, which means you can feed in these reviews and start present a word cloud of like high frequency words and whatnot. I think that was the initial how we initially did it. And a user can quickly select what is and is not and sift through all this data pretty quickly, and actually extract words of interest from the reviews and separate them from words that are irrelevant. And so this is really nice because it creates a training data set, a human annotated label training data set with limited effort from a human standpoint. And so now that we have this, what can we learn from it? How can this be used? And so, as I mentioned, this creates a very robust set of descriptors that are human annotated. And I must emphasize, as the number of you know in HCI, and some who are in machine learning, that anything that's human annotated or has human input is very valuable. So this actually can be used to train a deep learning model, where we take these, what we call potential descriptors, the ones that were annotated, we get extract the context from the reviews themselves, and we have the label of, is this or is this not a descriptor? This label is from the annotations. Then we do some deep learning magic and then generate a model. And so, in a simple way, what we can use this model for is to feed it a review, and it will tell us for every single word, what's the probability? High probability, it's probably a descriptor. Low probability, probably not. And so, as an example, these are some of the reviews we ran through the deep learning model, and the highlighted words have high probability to be descriptors. And if you kind of eyeball it, you can see that these actually are very interesting words that are used in this unique language. Oily, liqueur, fruit, chocolate. Some of these are pretty obvious in the adjectives, but some of them a little more interesting. Smoke was one that was very needed to be extracted because it's very unique to whiskey. And so this kind of gives an idea of how the results of this, and actually we went through and did some performance. This is preliminary performance results. And we found out that we're doing parts of speech tagging and we compare it to the human annotations, we're only getting an accuracy of 52, almost 53%, almost chance of whether or not the parts of speech tagging will be correct. Our deep learning model actually was getting almost 95% accuracy. So a huge difference, which we're very happy to see the results be so positive. And I threw in a couple precision recall, which is also a way to another couple aspects of looking at how well a model performs. I'm not going to go into details of these. I always forget exactly what they mean, but they're very important, especially when I present these to the machine learning community. But the higher the number, the better, kind of thing. So what are we going to do with all of this? Well, it's a good question. This project is multifaceted and there's a lot of directions and things that we can take as we move forward. And so one of them, as I mentioned earlier, is predictive analysis. Now that we have these learned lexicons, we can investigate our ability to predict different aspects of a whiskey based off of different aspects of the metadata, the quality, the price, the origin. Now, all this information is stored and was scraped from these websites. And so now we have a way that we can perform some predictions based off what we are able to extract from the reviews. And another part of that is trying to get this interface, working on an interface for how people can, the public, interact with this type of data and explore the data and kind of come up with, different aspects and understanding of, whiskey flavoring in that world. And no, we can do this for other food products. We're actually going to be presenting, I believe, at the Virginia Tech Science Festival. And we're not going to be talking to kids about whiskey. We're doing, I think we're going to be doing, excuse me, recipes for food. And so make it a little more kid friendly. And so here's an example of something that we can eventually automatically create is a whiskey wheel. And there are very few of these. And this is one of the few that we were actually found where this kind of breaks up the flavor profiles of whiskeys into different categories. And actually some of the current network analysis that's been done with the results of our deep learning model that Dr. Long has done is actually started forming some clusters that actually look like started forming a flavor wheel just from the results, which I thought was very fascinating. And so once we know what we want to show, we can start pulling things together and, getting input from the HCI world. You guys will be nice too. Because we have these ideas of selectable lists and everything, show different types of information, working through how to show this. This is kind of one of the next steps because, I want to make this accessible to the community. And ICAT really wants to see that too, which I know it's important no matter what. Because we have this wonderful science that we did, and we want to make it practical and useful for in an open way. And what's really interesting about this project, it got a lot of traction. It's been in a number of different news venues, including the VT News, the Library Magazine. ICAT has been promoting it. The Roanoke Star website called The Drinks Business. And we've been interviewed for a couple different articles already. Nothing's been published yet. But that's all I have right now. That's kind of where we're at with the project. I want to do a special big thanks to the people in the libraries who's helped us with this. And of course, a food science team who's really spearheaded all of this.